In this video, I'm going to be extending your knowledge of stopping distances, mainly for higher level candidates. So the objectives are to know what's meant by stopping, thinking and braking distances, which was in a previous video, be able to explain the factors, but also understand how to interpret distances from the highway code. Main aim of this video is to be able to determine distances from velocity time graphs. So we have this graph in the previous slide showing that the area under the graph is made up of two parts: the thinking distance, where you're traveling at a steady speed while you're reacting, and your braking distance while you're slowing down. So here are the factors, here are the things I want to focus in on. That when a force is applied to the brakes of the vehicle, work is done by a frictional force between the brakes and the wheels, which reduces the kinetic energy of the vehicle and the temperature of the brakes increases. The greater the speed of the vehicle, the greater the braking force needed to stop the vehicle in a certain distance. And the greater the braking force, the greater the deceleration of the vehicle. Large decelerations may lead to brakes overheating and or loss of control. Okay, so here's the actual from the highway code here. We're going to have a look and analyze some of this. You can see that at a faster speed, the overall stopping distance is much longer. If you look at the blue line, that's the thinking distance, the red is the braking. We're going to delve into that a bit more. So we just consider the first three. Compare the distances at 20 and 40. So how much times bigger is the thinking distance? Well, that's quite straightforward. It's just twice. And that's probably what you'd expect. If you travel twice the speed, you're going to travel twice the distance because you're traveling twice the speed, but in the same time. So that's a directly proportional relationship. Okay, distance is equal to speed times time. So speed doubles time, reaction time, and stays the same. But what about the other distances at 20? What about the braking distance? So at 20 miles per hour, it's 4 times less than a 40. It's 6 meters for 20 miles per hour and 24 for 40. So why is that? Well, twice the speed means it has 4 times the kinetic energy. And you've got to remember the equation for kinetic energy is half mv squared. So it's a squared factor. So if you square the velocity, if you double the velocity, v squared becomes 4 times. And because it's 4 times, you've got 4 times as much work to do. The brakes have 4 times as much work to stop it. So work done is force times distance. So the braking force, if it's the same, means you must have a distance which is 4 times. Hopefully that's explained that, a quite high level concept for you. You may want to go back and just review that if I've gone too fast.